Okay, now we're going to look at this the Buddy Phones pop sample. This is the first one I received. It has a gem-wrong PCB. I know that the PCB supplier has changed, but we'll take a look and see what we started with originally. So in order to test it, first we put this into pairing mode. Good, we'll pop it on the tester. Press go. It'll take a minute to get the device, call it, and make the measurement. And there we go. So this is the frequency response as it was sent. Now there was an obvious imbalance between left and right, you can see from these dips. And so what I did is made some additional portholes to balance it up. 3 holes at 2.5mm diameter. We can just store that curve, we'll measure it again and we'll see what happened after that. Didn't seat it too well, do it again. And we'll just okay, so anyway, these left and right, the dips are aligned. There's still a bit of difference between left and right in terms of level, but you can't really tune that out. That's just driver sensitivity variation. So you know, if you modified the design to suit this combination of drivers, you'll end up with something different than later on for each product. Good. And there's a couple of notes on the build. I noticed the silicon pad. It can come out easily if you play with it. A little bit there. Okay, so of course what's going to happen is kids will pick at that, it'll fall out, and you are not really able to get it back in very easily. Ear pads. Now a similar story. If you pull the ear pads off, it's going to be really difficult for a general user to put those back on. It's very narrow here. So, you know, people generally understand you have to hook it over there, but to actually get it to go in is rather tricky. With practice, of course, you can do it, but you can't expect your customers to be practiced at putting ear pads on and off. Another point just to raise is in terms of durability. So the cable comes along the top here through this little gap, and I can see when I'm moving the articulation, the cable's getting twisted and bent. You want to test that and make sure that the cable doesn't break, or at least has a long enough lifespan. Similar story for these sliders. One side is quite good. Another side has a little bit of a jam there. I can close it, but I suspect that the cable has got a kink in it. And again, this is one of these things, when you do that a few times, eventually the cable will just break, and so you have one channel dead. I thought it was very good otherwise. No sharp edges. You can't trap your fingers in there. One more point, the speaker grills. Generally you'd want to make this grill too small, the opening's too small for a screw to fall through. You know, it's a magnetic thing, otherwise in production from time to time a screw is going to jump in there. Next I got the sample. It is to be used with a new PCB. I believe the old PCB is still in this unit. Now it came with a different ear pad. This one has a fabric covering, where the other one was a leatherette. So we'll do the same thing, pairing mode. Put it onto the test. Press go, and we'll see how this compares to the previous one. And rather bad actually. So I noticed that okay, this side has the socket and plug, etc., buttons, so there's quite a bit of leakage in the rear chamber. Gives you a certain kind of response. In some ways it does have the same characteristic as the old sample, although the ear pad is different. However, on this side there were 2 tuning holes, and they've actually been covered up, so this side has real problems. The rear side is quite well sealed in this case. And so I don't know the reason why they covered these holes. Maybe they had something else in mind, I don't know. What we'll do is switch the ear pads over and we'll compare it. These are the ear pads from the first sample. We'll put them onto this sample and then we can make a comparison and see if the headphone behavior is essentially the same and if it's really only an earphone's difference, an earpad's difference I should say. Okay, maybe you'll get away with it. So pairing mode, onto the jig, make the test. Okay, now clearly the blue line, which is this side, actually the left, is the same for all intents and purposes as the previous sample, albeit the earpad is different. If I put on the same earpad, I get the same curve. Okay, that's not the case on the right here because the rear chamber has been changed significantly. Yeah, I don't know the reason. It seems that the holes were put there. They do a job. It's not quite enough. It needs more opening to have an equal effect as this side with the sockets and so on. Okay, so we've got the computer. We've got the computer out, and okay, we'll store that curve. We've got the computer out. We've started this software for setting the EQ, provided by the module vendor, I guess. They just have a Bluetooth connection. Here's the actual EQ software. So this is the setting, I presume, without any EQ. In order to set the EQ, we connect the computer to the phone with Bluetooth. We better set this to, I should have done this, prepared this before, never mind. Then we make an EQ function. Okay, so it happens that I already have one here. It's possibly this. Okay, now it is actually sending this EQ data to the headphone all the time. So by rights, this is already set now in the headphone. So all we need to do is just disconnect the computer. Then we can test. So the tester will connect through Bluetooth, send the audio. It seems that I cannot have both the computer and the tester connected at once, so we can't sort of do EQ on the fly changes. Alright, so this is not really the function that we want. This was set for the other earpads, so this is the kind of thing you see, you'll get these kind of differences. What we'll do is we'll reset it. I think perhaps if I just click here, I reset it to flat. Just for good measure, let's pack a bit of bass into it. We don't need to boost really anywhere there. And we'll see what that gives us. I think we actually have to connect. Yeah, we do have to connect quickly first, and then it's connected. I'll just make a little change to force it to send the data. Good. Should be done. Let's disconnect it and let's measure again and see what we get. Still not as flat as I want, so I can just keep iterating like this. Actually, this needs to go down a little bit in terms of frequency, and this also needs to reach down a little bit there. So around this, let's say 200, we want to come back by a couple of hertz, so we'll use this. Let's try that, but we don't have that right now. Here we go. Well, I think I notched that out a little bit too much, but we're getting a lot flatter there.